All right, so we're on to the next page. 31. Find the output for each input. Okay, let's talk about the vocabulary here. Find the output, which is like the y value, okay? Whatever you get once you put in your input for each input. So your input's your x value, your output is your y value. All right, now on your graph, looking at your graph, we have, instead of f of x, we can think about this as y, the y value. All right, it's for whatever x value you plug in, that independent variable, you're going to get spit out some y value. Let's take a look. So f of -4. So your x value is -4. Let's go to our graph to see where x is -4. 1, 2, 3, 4. This is -4. So let's take a look at what y value we have for our graph. So along this vertical line where x is -4, right here is where we would touch our graph. Now, this point would be -4, comma, our y value would be 2. So that means that when you plug in -4, you get an output of 2. Your y value is 2. Let's take a look at the next one. F of 0. So we're going to go to where x is equal to 0, which is right here at the intersection point. Turns out your graph is actually passing through the origin. So when x is 0, your y value is also 0. So 0 is going to be your output. Take a look at the next one. F of 5. So we're going to plug in 5 for x, and we're going to see what our y value turns out to be, our output. So going to your graph at 5, this is 1, 2, 3, 4, 5. So this is 5, and we're going to hit our graph right here at this point. So this would be 5, comma, y value of -1. So -1 is your output. And lastly, f of 2. So 2 will be right here, and we're going to hit our graph right here, which is at 2, comma, -2. So our output is -2. So we have each of the outputs listed for the inputs. Remember, output is y, input is x. All right, let's move on. Number 32. Identify the zeros of the graph below in set notation. Now, zeros are also known as your x-intercepts. So wherever your graph crosses the x-axis, you're going to identify what that x value is where it crosses the x-axis, and that's called your zero. So we're going to write our answer as x equals, and in set notation, okay, we're going to put the different values of x where the graph crosses the x-axis. So one of the places that it crosses the x-axis is right here, which is at -1, -2, -3. So -3 is one of our zeros. The other place where the graph crosses the x-axis is right here, which is at 1, 0. So it's just 1, okay? Now remember, you're looking, when you find the zeros, you're looking for where your graph is crossing this x-axis. And whatever value it crosses the x-axis at, that is called a zero. All right, let's move on. Find the slope of the line passing through the points 6, 3 and -4, -2. So we're finding the slope of a line, and we're given 2 points. To find the slope, m, of a line, when you don't have a graph, you're going to use the slope formula, and it looks like this. M equals y2 minus y1 over x2 minus x1. Whenever you have a formula that involves a negative, you have to be very careful when you're plugging into the formula so that you don't forget the negative. So let's take a look at how we would plug in. Your first step when you have your 2 points is to decide which one is 0.1, which one is 0.2. So let's say 6, 3 is 0.1, so we'll call this x1, y1. And the second point is x2, y2. Let's go ahead and let's plug into this equation. So I'm going to draw my denominator, or rather my division line. And I'm going to do, in the beginning, I'm going to go ahead and I'm going to draw the negative that's between y2, y1 and x2, x1. I'm going to draw that there because I want to not forget that I have to subtract the points. So let's get started. I'm going to plug in for y2 our -2. The minus is already there. Then y1 is 3. For x2, I have -4. Minus, and then my x1 is 6. Okay, let's go ahead and simplify. -2 minus 3 is -5 over -4 minus 6 is -10. The two negatives are going to cancel. It's going to become a positive. Now, 5 over 10 is not your final slope. Slope should always be in simplest form. You can divide the top and bottom here by 5, which is the greatest common factor, in order to simplify this slope. So I'm going to divide the top by 5. I'm going to divide the bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So my slope between the 2 points is 1/2, 1 over 2. All right, let's go on to the next question. 35. Find the slope of the line passing through the points 5, -4, and 3, -4. So again, we're looking to find the slope, m, of the line. And we're not going to do it graphically. We're going to do it using the equation. So again, you're going to write the equation, m equals y2 minus y1 over x2 minus x1. Decide on your x1, y1 and your x2, y2. I'm just going to do it in order. x1, y1, x2, y2. Now, I hope you notice that your y values are actually the same. They're both -4. So let's see what effect that has on the slope. Plugging things in. We're going to start with -4 minus. Remember, you always write the minus and then look at the other point. So -4 minus, and now let's look at the y1. y1 is -4. So -4 minus a -4. Let's look at the x's. 3 minus. I always put the minus before I look at my point so that I don't forget it. And the x1 is 5. So 3 minus 5. Let's go ahead and simplify this. The two negatives make a positive. So it's -4 plus 4, which gives me 0 over 3 minus 5, which is -2. 0 divided by -2 is equal to 0. 0 divided by any number gives you 0. So this is going to be a slope of 0. So the line with a slope of 0 is horizontal. Remember, hoi. It's a horizontal line that has a 0, 0 slope. And it's a y equals line. So that's hoi. In order to get a vertical line, just that you're aware, to get a vertical line, if this was switched, if it was -2 divided by 0, if your denominator has the 0, that's when you get an undefined slope. That's when you get a vertical line. So when the x values are the same, you get an undefined slope. Here, our y values were the same. So that's how we get a 0 slope, a horizontal line. All right, let's move on. Number 36. What is the slope of the line 3x plus 7y equals 28? So they're asking for the slope. Now, this line is not in slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b. when your line is in slope-intercept form, it's very easy to tell what the slope is. It's your coefficient to the x value. But if it's not in y equals form, then you have to get it into y equals form. This format that it's currently in is called standard form. So we're going to convert this into slope-intercept form, y equals mx plus b. In order to do that, we're going to start by moving the x value. Okay? Our goal is to get y all by itself, so we're going to start by getting rid of the 3x from the left-hand side. So 3x is positive right now. Let's subtract it from both sides so that we can get it to the right. They will cancel on the left. Now we have 7y equals negative 3x and 28 can combine. They're not like terms. So we're going to put them next to each other. Negative 3x plus 28. And now we're almost at the point where y is by itself. The last step is to get rid of the 7 in front. So we're going to divide every single term by 7. Every term needs to be divided by 7. This cancels. So now we have y equals negative 3 over 7. You're just focusing on the numbers. Negative 3 over 7x. And then 28 divided by 7 is 4. But we don't really care about the 4. The only thing we care about is the slope, which is the number in front of x, the coefficient. So our answer is m equals, the slope equals, negative 3 over 7. So key takeaway here, always put your equations for lines in slope-intercept form so that you can quickly identify the slope. Number 37. What is the equation of the line below in slope-intercept form? Slope and intercept. Slope-intercept form is y equals mx plus b. The reason it's called slope-intercept is because you have the slope and the intercept clearly defined in the form of the line. So what we have right now with x's and y's on the same side of the equation is you have this in standard form. So let's go ahead and do the work to get y by itself. First step is to move the x values. Right now we have a negative x. So we're going to add x to both sides. This will cancel. So now we have 5y equals x positive plus 9. Remember, you can't combine an x and a whole number. So you're just going to put them next to each other. And the x values should go in front. Next step, you're going to get rid of this relationship between the 5 and the y. So you're going to divide everything by 5. The 5's will cancel. So now you have y equals, remember in front of the x there's an invisible 1 there. So really you're dividing that invisible 1 by 5. So you get a 1 over 5 coefficient to x. 1/5 x plus 9 over 5. And I'm going to leave it just like that. So this is the equation for the line below in slope-intercept form. Okay, next question. Number 38. Identify the x and y intercepts for 10x plus 4y equals negative 20. Now, I want you to think about a graph. When you have a graph, the x and y coordinate grid, your line, for example, if this was my line, my x-intercept is where I cross the x-axis. Now think about it. When I cross the x-axis, that means my y value is 0. So maybe this point right here that I just mentioned could be 1, 0. Okay? So my y value is 0 when I'm looking for my x-intercept. Y is 0. Now, if I'm looking for my y-intercept, in this particular example, maybe it's right there. So if I'm crossing the y-axis, that means my x value is 0. So maybe this point here that I just highlighted in yellow is negative 4 comma 0. I'm sorry, not negative 4 comma 0. 0 comma negative 4. So when you're looking for a y-intercept, your x value is going to be 0. So in this equation, we want to find the x-intercept and the y-intercept. So if you're looking for the x-intercept, make y equal to 0. When you're looking for the y-intercept, make x equal to 0, the opposite. And then you're going to solve. So let's look for the x-intercept first. If I'm looking for the x-intercept, I'm going to make y equal to 0. So let's go ahead and plug in 0 into 4. So on the left, I'm going to have 10x plus 4 times 0 equals negative 20. So 10x plus 4 times 0, well, this is going to get rid of everything. It's going to be 0, and I don't need to write that. So 10x equals negative 20. Divide both sides by 10. So x will equal negative 2. So my x-intercept is negative 2. Now for my y-intercept, that's when I'm going to plug in x equals 0. So let's go ahead and do this one more time, but now for the y-intercept. So I'm going to do 10 times 0 plus 4y equals negative 20. 10 times 0 is just going to go away. It's going to give you 0. So you're going to have 4y equals negative 20. Divide both sides by 4. 4's cancel. So y equals negative 5. So my y-intercept is negative 5. So the key for these problems, if you want to find an x-intercept, plug in 0 for y. If you want to find the y-intercept, plug in 0 for x. Plug in 0 for the opposite variable. Let's go on to the last question on this page. 39. Which is true given the linear equation below? A, it has a positive slope. B, the x-intercept is 10. C, the y-intercept is negative 5. D, it passes to the point negative 1, 2. Okay, well, starting with A, when it says it has a positive slope, I don't really know what the slope is when it's in this form. I like to look at it in slope-intercept form in order to be able to tell what the slope is. So I'm going to go ahead and I'm going to convert this into slope-intercept form. Step 1, you're going to rewrite it. So 10x plus 4y equals negative 20. Start by moving the x. In order to get the y by itself, start by moving the x. Subtract 10x from both sides. So now we have 4y equals negative 10x minus 20. Can't combine them, so I just put them next to each other. Then you're going to get y by itself by dividing every term by 4. So the 4's cancel. So now you have y equals negative 10 over 4 x, and then negative 20 divided by 4 is negative 5. All right, last thing, this negative 10 divided by 4, since both the numerator and the denominator are multiples of 2, I know I can simplify that. If I divide the top and bottom by the greatest common factor of 2, I'm going to simplify this slope. So I get y equals negative 10 divided by 2, which is negative 5, over 4 divided by 2, which is 2, x minus 5. Okay, so that is my converted equation now. So now it's y equals negative 5 over 2, x minus 5. First question, or rather first choice, it has a positive slope. Nope, In fact, it has a negative 5/2 as a slope. So it's not choice A. Choice B, the x-intercept is 10. Well, if we remember, this is the same thing we did in the last problem. Our x-intercept is when we plug in 0 for y. Our x-intercept turned out to be -2. So I would say no, it's not choice B. It's not 10. It's actually -2. Choice C, the y-intercept is -5. Well, we did it before, and our y-intercept turned out to be -5. So I do like that choice. So I'm going to say I like that choice, and I'm going to select it. But I want to test the last one as well. So D, it passes through the point -1, 2. Now, to test if something passes through a particular point, you want to make sure that that point works in your function, or rather your equation. So if I plug in x and y into my equation, then I should get a balanced equation. So I'm going to take my equation in standard form without any fractions. 10x plus 4y equals -20, and I'm going to see if I get a balanced equation here. So it's going to be 10 times 1, -1, plus 4 times 2 equals -20. 10 times -1 is -10. 4 times 2 is 8, which equals -20. -10 plus 8 is -2. That does not equal -20. So this point is not on the line. It doesn't work. So I'm not going to select choice D. So the correct answer is choice C. And just so that you understand what this graph would look like, I'm going to draw a quick sketch. If this is my x and y axis, I have a -5 as a y-intercept. So imagine that's all the way down here at -5. And the line has a negative slope. So it would look something like this. This is a very rough sketch, but that's what it would look like. A negatively sloped line passing through -5 on the y-axis. Okay, we're done with this page. Let's keep moving.